Here in Chapter 10, we're going to be comparing two populations or treatments. So we're going to be looking at significance test and hypothesis testing all at the same time. Just like we did in Chapter 9, only we have two groups. So by the end of this section, we're going to be able to describe the shape, center, and variability of the sampling distribution of the difference of sample proportions, and to determine whether the conditions are met for doing inference. This is going to be our first video. The next video is going to be constructing and interpreting a confidence interval. And then the next video will be calculating the standardized test statistic and p-value. And the last video is going to be performing an entire significance test. I'm also going to add in two other videos with a full-on example of hypothesis testing and confidence intervals from beginning to end. Let's start with an example. At school 1, 70% of students did their homework last night, so P sub 1 is 0.7. And at school 2, only 50% of the students did their homework last night, so P sub 2 equals 0.5. The counselor at school 1 selects a simple random sample of 100 students and records the proportion, P hat sub 1, that did the homework. And then similarly at school 2 with a sample size of 200. Notice the subscripts. Since we have two groups now, we need to be able to identify, in this case proportions, what p-value equals what, proportion equals what. So we're denoting that the first school has a subscript of 1, and the second school has a subscript of 2. So let's look at the shape, center, and variability. This goes back into Chapter 6 when we were talking about random variables and combining them. We had Pete's Jeep tours and his sister Erin's adventures. And we looked at when we're combining random variables, what rules do we use? So let's look at them individually of their sampling distributions and then look at their differences. So you have your normal conditions that you are checking for your shape, center, and spread. Sampling distribution for the first school, it's approximately normal because n times p and n times 1 minus p are both greater than or equal to 10. Same thing for school 2. N times p and n times 1 minus p are both greater than or equal to 10. Then we also learned that the center of the sampling distribution is equal to the parameter value claimed. So we have 0.7 and 0.5. And then as long as your sample is less than 10% of the population, then we have the formula square root of p times 1 minus p over n to be our standard deviation. So we have those individually here. Now let's look at the difference. So here is a simulation of a sampling distribution between the sample proportions of those schools. One set of samples gives p hat 1 is 0.72 and p hat 2 is 0.47. The resulting difference, if you look here, is 0.25, which is exactly the difference of these two values. The standard deviation, if we're combining them, remember if we are subtracting two random variables, we combine their standard deviations by adding their variances. So we have the square root of p times 1 minus p over n plus the other sampling p sub 2 times 1 minus p sub 2 over n sub 2. So we get a standard deviation of 0.058. And look at the mean of this difference. It is 0.2. Remember, p1 was 0.7 and P2 was 0.5. Well, what's the difference between these two? 0.2. So, what does that mean for us? It means that the difference in the sampling distributions is approximately normal if the large counts condition is met for both. So we have to check that n sub 1 and p sub 1 is greater than or equal to 10, n sub 1 times 1 minus p sub 1, and so on and so forth for both populations are both greater than or equal to 10. The mean of the sampling distribution is equal to the difference of the two parameter values. And again, the standard deviation is combining their variances. So square root of p sub 1 times 1 minus p sub 1 over n sub 1 plus the other, as long as the 10% condition is met for both samples. So let's look at an example. Your teacher brings 2 bags of colored goldfish crackers to class. Bag 1 has 25% red crackers and bag 2 has 35% red crackers. Each bag contains more than 1,000 crackers. Using a paper cup, your teacher takes a simple random sample of 50 crackers from bag 1 and a separate simple random sample of 40 crackers from bag 2. Let p hat sub 1 minus p hat sub 2 be the difference in the sample proportions of red crackers. First, I would like to say, in general, it does not matter which order you are doing the subtraction. It's all based on the results that you get and what that interpretation is. However, in this particular problem, it's telling you the difference to take. It's the first bag minus the second bag, so you must do it in the order dictated. So what is the shape of the sampling distribution and why? Find the mean of the sampling distribution and calculate and interpret the standard deviation. Well, the sampling distribution is approximately normal because checking all four, n times p, n times 1 minus p for both groups, all are greater than or equal to 10. Therefore, it's approximately normal. The mean of the sampling distribution is simply the subtraction of their parameter values, 0.25 minus 0.35, so negative 0.10. And because 50 is less than 10% of all the crackers in bag 1 and 40 is less than 10% of all the crackers in bag 2, we can calculate the standard deviation. And what does the standard deviation mean? The difference, bag 1 minus bag 2, it is important to state the order of subtraction. And the sample proportions of red goldfish crackers typically varies by about 0.097 from the true difference in proportions of negative 0.10. The interpretation is the same as it has been in previous chapters. The only difference now is we are talking about the difference. So you're not talking about just the sample proportion, it's about the difference in sample proportions.